Okay, so now that we have talked about what is an exponential function, how to evaluate it, can we look at a graph, at a table, can we look at a set, can we determine if it's exponential? Now we're going to look at graphing them. And so what do they look like when we graph them? So we know lines look like this or like that. We know parabolas look like this or like that. So what do exponential functions look like? So let's go ahead and graph our first exponential function. So we've talked about evaluating them, so we should know how to evaluate it. So we have 2 times 3 to the x power. So we're going to use a table, because a table is something you use that if you don't know how to graph it, a table always works, as long as you know how to compute properly. So we're going to plug in -2 in for x. So this is going to look like 2 times 3 to the -2 power, which is really 2 times 1 over 9, because this is really 1 over 3 squared, which gives us 2/9. Now for graphing purposes, I'm going to go ahead and figure out what that is as a decimal. So I believe it's 0.2 repeated. So now I'm going to go to my graph. I'm going to go to -2. I'm going to find about 0.2 repeated, so probably right about here. Okay, now I'm going to do 2 times 3 to the -1 power. So this is really 2 times 1 over 3 to the first power, which is really 2/3. So now when I calculate 2/3, I'm actually going to get 0.6 repeated. So I'm going to go ahead and put that in my table, which means now I'm going to graph the point of -1 and 0.6 repeated. Okay, so the next one, 2 times 3 to the 0 power. Well, we talked earlier, anything to the 0 power is really 1. So this is 2 times 1, which is 2. And so now we have the point 0.2. So now we're going to plug in 1. So 2 times 3 to the first power, which is 2 times 3, which gives us 6. So now we have the point 1.6. And now we're going to calculate the 2. So 2 times 3 to the second power, which is 2 times 9, which gives us 18. Whew. So 2 and then 18. So now we're looking at that, and so let's take a real good look at this. So now when I graph it, what's going to happen is I'm going to come really close to this x-axis, but I'm never actually going to touch it. And then I go up and I go up and I go up, and it just gets steeper and steeper and steeper as we go farther along. And so this is what an exponential function looks like. Now this particular exponential function is known as exponential growth. Why is it exponential growth? Well, it's exponential growth because as I go to the right, because typically in the United States when we read left to right. As we go to the right, it grows and grows and grows and grows faster and steeper. So it's continually growing and just getting steeper and steeper and steeper. So this is what we call exponential growth. And our graphs will always look like this, like it hugs that x-axis and then goes up steeper and steeper. Now there's something I want to talk to you about, and that is our y-intercept. So you look here and you see that our y-intercept is at 0.2, which is right here. Now something I want to point out to you is that 2 really comes from this 2 right here, because anything to the 0 power becomes 1. And so that number in front will always be your y-intercept. So it's a little thing that we can use to kind of help us graph. And then something else that we may notice is that, here, let me grab a different color, is this is 3. So once I get this starting point, I can times by 3 to get the next numbers in there. Because remember, this is a common ratio. So going back to those geometric sequences, I times by 3 each time as I move forward. But as I move backwards, I divide by 3. and I divide by 3. So these are little things that we can use to help us calculate that table a little bit faster. But you don't have to use that method. You can go through and calculate each time. So let's calculate another one. We're going to graph negative 5 times 2 to the x power. So we're going to start by plugging in negative 2. So this is negative 5 times 2 to the negative 2 power. So this is really negative 5 times 1 over 2 to the second power, which is really negative 5 times 1/4, which is really negative 5/4. And as a decimal, it's negative 1.25. Whew, almost ran out of room. So in here, this is negative 1.25. So we're going to graph that. So negative 2, negative 1.25. And then we're going to plug in negative 1. So I'm going to move down here where there's more room. So negative 5 times 2 to the negative 1 power, which is negative 5 times 1 over 2 to the first power, which is really negative 5 over 2, and as a decimal, negative 2.5. So now when I'm looking at this, this is negative 1, negative 2.5. And so now I'm going to plug in 0. And if we looked at our shortcut earlier, we kind of know where this should go, but let's check it out. So negative 5 times 2 to the 0 power. Well, anything to the 0 power is 1, so this is negative 5 times 1, which is negative 5. So again, making sense that this number is our y-intercept. And so now we're going to go ahead and look again. So negative 5 times 2 to the first power. So negative 5 times 2, which gives us negative 10. So 1 and negative 10. And the negative 5 times 2 to the second power, which is negative 5 times 4, which is negative 20. So 2 and negative 20. So again, looking at this, again, it's going to hug the x-axis and then get steeper and steeper down. So this is a negative version of what we just graphed. So this is really just reflected across our x-axis, opening down. We're still seeing that this value right here is our y-intercept. We're still seeing that each time we times by 2, so negative 5 times 2 times 2, and then we move backwards, divide by 2, divide by 2. And so seeing these patterns that exist with exponential functions. Okay, so next one. 3 times 1/2 to the x power. So we're going to try negative 2. So 3 times 1/2 to the negative 2 power. So this is really 3 times, and I'm going to flip this around, and this is now going to be to the second power. So that negative, again, just flipping things. If it's on top, it goes on bottom. If it's bottom, it goes on top. So this is really now 3 times 2 to the second power, which is really 3 times 4, which gives us 12. So negative 2 and 12. And then we're going to go ahead and calculate the next one. 3 times 1/2 to the negative 1 power. This is really 3 times 2 over 1 to the first power, which is 3 times 2, which is 6. So negative 1 and 6. And then 3 times 1/2 to the 0 power, which is 3 times 1, which gives us 3. Again, seeing how this becomes our y-intercept. And what do you notice? Well, I'm timesing by 1/2 each time. So what is 3 times 1/2? Well, 3 halves, which is 1.5. And then times by 1/2, 0.75. So again, we can calculate it, or we can use those patterns that we studied with the geometric sequences to help us out. So 1 and 1.5 and then 2 and 0.75. And so now we're starting to see that as we move to the right, our graph gets lower and lower and lower, and then it starts hugging the x-axis. And so this is what we call exponential decay. And so how can we tell the difference between growth and decay? Well, we can tell it by looking at our graph. As it gets lower to the right, then it's decay. If it gets higher to the right, it's growth. Something else that you can do is notice that if this number is smaller than 1, that means that it's going to make it go smaller and smaller each time. But if the number is bigger than 1, it's going to make it grow, grow, grow more and more. So looking at those numbers help us determine what's going to happen to the graph. And we can do that just by analyzing those patterns of numbers. So next one, we have negative 4 times 1/4 to the x power. So when we calculate, oops, helps if I'm in pen mode. So negative 4, 1/4 to the negative 2 power. So this is really negative 4 times 4 over 1 to the second power, because again, the negative makes that flip around. So this becomes negative 4 times 16, which gives us negative 64. Whew! So let's see, negative 2, and this is negative 64. It doesn't even fit on our graph. Okay, let's move to the next one then. We're going to go ahead and put in our table so that way we know it's just really low. And then negative 4, 1/4, negative 1 power. So negative 4 times 4 over 1 to the first power, which gives us 16. Negative 16, sorry. So now negative 1, negative 16. Okay? And then we should know that here it's going to just be this number, negative 4. So 0, negative 4. And then at 1, so this is negative 4 times 1/4 to the first power, which is just negative 4 times 1/4, which gives us negative 4 over 4, which is negative 1. So now we're at 1, negative 1. And as you can tell, we keep dividing by 4 each time. Why? Because this is 1/4. So I times by 1/4, I times by 1/4, I times by 1/4. So this is going to give us negative 1/4, which is 0.25. So again, using those patterns, using those ideas to help us out. And again, seeing that pattern that exists for exponential functions. And that's it for graphing exponential functions and looking for those patterns.